Any suggestions for problems from Leetcode? Can also be binary search.io. That won't be the end of the world. Have you ever seen subscriber in the street? Not in Warsaw, but in some programming events a year ago, yes. What's most funny, I would say, but 1 minute, need to do something first. Stream pings. Right, yeah. So now it's not that I see a lot of people, you know, like real face-to-face seeing. But it used to be the case that when I go to some kind of small party, I don't know, gathering around 10 people, something like that, to drink a little bit, to talk with friends. Often there will be a person I don't know who knows me because it's, you know, generally a circle of programmers. I mostly know programmers or people who studied math or programming, and their friends often are from the same faculty. So I would go to a random party and some person would know me because of YouTube. Love from Singapore. Thank you. Graph theory. Binarysearch.com breaks string into words. String ad hoc. From Romania. Iron. Thank you, thank you, thank you. What is this? Suggested by Skier. Skyer. Lexicographically small subsequence of S that contains all the distinct characters of S exactly once. This question is the same as 316? That's... I wonder if they realized that before creating this problem. That's an unusual note. Okay, let's do this. I like the problem. Uruguay. Whoa, that's not a big country. I mean, not a country where I have a lot of viewers. And hey, from India. I would be surprised if nobody from India watched. Half of my viewers are from India. All right. If we have BC, ABC, then we can take ABC. Okay, that's not very helpful. What's this? QR code? Send this page? No. Okay, the second one is maybe more meaningful. We have a lot of characters, but in particular there are characters A, B, C, D. All of them we need to incorporate we need to include in our subsequence. In particular, we need to take A. And in this case, of course, if possible, we should put A at the beginning. And it turns out possible, but we cannot take AB and then something. Perfectly, we would want to print ABCD, but there is no subsequence ABCD here. Second best is ABDC. This is second best. But apparently it also is not a subsequence. All right, then you have a little bit to think about this problem, and then I will show you a solution. I mean, we will slowly get there. I will say something about intuition for a solution. Must I major in computer science at university? Can I stick to mathematics? You know, computer science... okay, good question. But what will you do with algorithms, Abzub? If you want to do algorithms, if you want to use them and like improve currently best algorithms, stuff like that, then doing computer science will be very useful. There are some people who do mathematics and then, study the mathematics, but then do algorithms in their job. But it's hard to do algorithms without proper programming knowledge and practice. Yes, I know a solution here, I think. Is this dynamic programming? Maybe in some way. Mostly interested in theory. Then math seems better, but a job is very rarely just about theory. If you want to live and have money, then maybe you should do computer science too. Unrelated, but could you help with this one? Not right now. Not during a stream. Hi Lakshay, welcome back to the stream. Right, let's do the problem. We want to start with A if possible. That's the most important thing. If you want to, in a dictionary, if you want to find a word that is as early as possible, then the most important thing isn't its length or the last character, anything like that. It's the first character. If possible, we should take A. So let's try to understand if, given this string, we can take some subsequence with A as the first character and all other characters still occurring. Well, for that, I should look for A and see if all BCD appear on the right. In this case, they do appear on the right. What if there are multiple A's? What if the string is like that, where the second A is here? So right now I have a choice between two A's. Then it's enough for me that any choice is viable for A and then BCD in some order. So let's take the leftmost A because more characters are available to the right. Choosing something more to the left is better because I have more possibilities for how to finish the string. So let's always find leftmost occurrence or first occurrence of A. Check if all other characters occur to the right from this A. Actually, it's not always A, it's just the smallest character. Maybe S doesn't have A. But we should just, if the string is BCBC, then the smallest possible character is A. Not A, B. DMOJ, I didn't use it much. In Poland, maybe just people don't use it much. All right, if that's the case, then I know that I need to take this A. And then I have a smaller problem. If this is not the case, then apparently I cannot take A first. So if yes, then take this A and continue with B and forward. And if no, then I cannot make A to be the first character and instead check B and so on. Check then C, D, and so on. Check B as the first character. Just like here, I checked A as the first character of my subsequence to print. Writing some kind of code will help us to understand the complexity of that, because it will be a bunch of for loops. So I will first examine if A can be the first character, then B, and so on and so on. I can make a for loop for that, for every first possible character from A to Z. Let's check where is its leftmost occurrence. While S of I is not first, I++, assuming that this character exists, then I'm just moving from index 0 and trying to find its first occurrence. Right, now I is the first occurrence of character first. What do I do now? I need to check if to the right from me there are all other characters. let's use some kind of n. N will be length of s, and also I need it here. Well, I smaller than n, and otherwise I would get out of bounds error. I cannot. If I'm out of the array, it means that I didn't find any occurrence of this character. Right, and now in some way let's say that this character does appear, like appears of s of j is true. And to make it fastest, instead of some kind of dictionary, I will use a Boolean array of size 26. By subtracting a, I have a value from 0 to 25. Arrays or vectors are faster than maps or dictionaries. And now I need to check if there is some character that is present in the full string, but not here. So if, like here, if after taking a, I could on the right find all BCD, all characters that in total they appear. So let's call this in suffix. And let's call stuff that appears at all, let's call it at all of 26. For every character in S, at all of this character is true. Then I know what characters I need. Alright, check if in suffix, and now for every character, if it appears at all, but not in the suffix, then this is bad. I have Boolean flag OK, that everything is OK. If not OK, then continue. Try the next first. Otherwise, this is the first character. Let's say that we print the answer, one by character, then I would print this. Yes, a loop executing n over 2 times is O of n. This exact problem was in DMOJ contest. Well, it's not really some, grand new problem. I wouldn't use it in anything like Code Forces contest. All right, but we don't want the first character. Like if we are putting a at the beginning, then in the remaining part, in the suffix, we want everything except for this character because it's already here. So let's say that here I do right now from I. So this now is including s of I, including this very character. Also this I smaller than 1, I will remove it and just guarantee it here. If not at all of first, then continue. This way I guarantee that this character does exist. So I will only examine, like here, ABCD as possible first character. What happens though after we put a character, which is something, by the way, that in general you should do before coding. It isn't a good practice that I jump to solving that I jump to implementation before thinking through all the details. Maybe not all the details. It's fine to leave some detail to the implementation, but you should see roughly what the solution is before starting to implement anything. Well, I knew how to solve it. I just didn't explain it. But let's review what we have right now. We check what characters appear in S. Then we try every possible character to put on the first position of a subsequence. Preferably it's A, if not then B, and so on. This character must appear at all. If it doesn't appear, then continue, because you will not find it. Find the leftmost occurrence. Find leftmost occurrence of this character first. Then check which characters occur in from I up to n minus 1. So what can I take after this character? And then we check if all characters appear there. If something was available at all in the string, but it isn't in this suffix, then this is bad situation. Is this the first problem? Yes, it is. So you didn't miss much. All right, what do we do after printing that? Well, for this string, if I detected that A is a good first character, then I'm left with this part, and I don't want to take A anymore. I should ignore it in some way. Let's say remove it, turn it into space or something like that. I could literally go and turn it into some 0 character or space, but what about just saying that at all of first is false? So I pretend that this character doesn't exist anymore, and thanks to that, in every next run, it will be ignored. I will not try it as this character. Also here, when checking if remaining characters do appear in the suffix, I will not check for it, because it's already there. So I will never use A anymore, or actually the first character. If first is C, then C minus A is 2. So this is character casted into value from 0 to 25. Okay, actually I don't want to print first, I want to gather some kind of subsequence. Append this character first. All right, and one other thing is that if after I took A, I only can do stuff to the right from it. I need to remember in some way from where I can go. I think a good variable for that is start. So I starts from this, only from there, and also if you took it, then start becomes I. So start is I was this previous character to take. It can even be I plus 1. Like if I took A on this position, I need to start searching from the next position. Actually, start and I are the same variable. I could just use start, or just use I. But maybe this is more meaningful. Oh, got some wrong answer. I didn't get all the characters. I got A, C, and then I printed D, while I should say B. Right? I said A, C, D, and then I should also grab B. What's going on? Oh yeah, I should repeat it all the time. Right, while true. So I just consider all characters from A to Z once, and that's it. That's far from correct. I need to many times go and find something. If we indeed achieve this, then break, because you found it. If you found that D is a proper character to take now, then don't try E. And for the next position, we want to try every character starting from A. And just this right now is infinite loop. I need to say that if I already am done, then we should stop. One way to do it should be this. Check that at all only contain falses. Because every true, when I use a character, I turn into false. This should be good. Empty output, while at all is different than that, of course. Ellipsoid, please speak Polish. What I mean is please speak English. But how many problems will we solve? As many as we can in around 2 hours, maybe a bit less. Temperature below 0 degrees in Warsaw? Yes, but it's not a big deal. Fine. I said that once we implement, it should be easy to say what's the complexity. We repeat at most 26 times. This while loop it will happen at most 26 times, because that's how many characters we will put in the subsequence. Then the second for loop is also 26, so alphabet size. 26 times 26 times, here you're finding the next occurrence of something, so that's n. What else? Here we also have n, kind of independent, so n plus n, just like once n. Here we have 26. Seems to be 26 times 26 times whatever inside, and inside is n plus 26. And it's best if you deal with some alphabet to just say that there is some variable denoting the size of alphabet. Then I have a square multiplied by n plus a. In other words, that's n times a square plus a cubic. You can argue that alphabet size is constant here, it's 26, then it's just O of n. But for sure it makes sense to try to optimize it and get rid of a, for example. It's enough to solve this problem because n is only 1000, but it for sure can be solved faster. How are you feeling now? I'm fine. I am fine. What if the string is this? I can analyze what then. Well, I will first try a. I will find the leftmost occurrence of a, and I will investigate if after this a I can take all remaining characters. I cannot, because in this suffix there is no BCD, right? The next best character to take is b. Can I take b, and after that do I have all remaining characters? Nope. Can I take c? Yes, I can take c, because on the right there are all remaining characters, a, b, d. So c will be the first character to take. So subsequence is first c. Then we start from there. Start is 1, so we start from here. And again, we try a. That doesn't work. We try b. We try d. And we can take d. After d, there are all remaining characters, a, b. So subsequence becomes cd. Then we split here, which just means that start is here, it points to b. And we try a, we try b. I think this will be the subsequence. We can try it and just run for this test if we have any doubts about that. Run, and I want to run for this. CDBA, yep. That's good. Let's try to optimize it a little bit, improve the complexity. What do we do inside? We find leftmost occurrence of something, we check what occurs in the suffix, and we check all 26 characters. N seems to be the biggest thing here, so let's try to improve it and get rid of n. This part finds the after some position start, finds the next occurrence of a character. That should be easy with preprocessing. As preprocessing, you can create a two-dimensional array, next occurrence, where for every character and for every position, you know where it occurs next. We will do this to improve this part, O of n part, to get rid of a times n. And then we will also need to know for every character if it appears in a suffix. But that's even easier. Let's focus on this first, which is quite a common technique and you need to know it. It's not just specific for this problem. It's very standard. All right. If for the first position you try to find the next occurrences for everything, then for second position you will do a lot of work all over again. Instead, it's better to start from the end, because that turns out more useful. Almost always next occurrence of any character starting from this position I is same as next occurrence for the same character from the next position. Like if I tell you that starting from position 10, character Z appears on position 15, then so the next occurrence is 15, then almost always starting from position 9, this character also the next occurrence is on position 15. The only exception is if position 9 is this character. Yes, so for every character from 0 to 25, this value of something from A to Z, let's call it next. Next occurrence of CI is next occurrence CI plus 1. But we need to overwrite the character that occurs exactly on position I. This character, its next occurrence is exactly here. Okay, that's it. Easy, n times 26. Also because I iterate over I first and then over C, that it's better for cache to use it like that. The first for loop most of the time should go as the first dimension. If you want to understand more about this and why this is the case, read about cache. All right, well, n I already need for that. And in C++, okay, you can create it like this, of n and 26, but it's a bit better to use vectors. I will switch to vector later. What about I equal to n minus 1? Is premium worth it? Only if you already spent a lot of time, I would say. If normal problems are not enough for you, then sure, get premium. If you're just starting with Leetcode, then nope. What about I equal to n minus 1? Then I have some kind of error here. And generally, what do I want for a character that doesn't appear to the right? Well, I use it only for characters that I know appear, because I check it here. That it's like, otherwise my program would completely fail. But I guarantee it when taking every next character that still all other characters are remaining there. So this should always be possible, so I don't need to care about what happens at the very end, which means that it's very crazy to do so. Of n minus 1 C, I can, or maybe nc, I can put this as 12 or whatever, because I claim that I only will check values that are overwritten here anyway. So here it could be any random value. I claim that this thing will work. We'll see. Now also I started using n plus 1, because from 0 to n. So for position n, for a fake position, I say next occurrence for every character is this kind of infinity. But also I could put, I claim here, I could put 1, I could put 2, could put 0. Then I keep copying it. This will mean, well, infinity. And sometimes I overwrite, and whenever for some position, for some character, it appears here or on the right, it will be a meaningful value, because this eventually will be overwritten. Where is power stable of this? Much faster than that in my code versus submission. Yes, I guess it cached, but I didn't see your code. Alright, so this is 26 times n. And now let's use it here. Find leftmost occurrence. This is exactly next occurrence of I, of start, of character first. So from O of n, we change this now to constant, after we have preprocessing. Let's run this code and submit again to make sure that it works. What's wrong? Index out of bounds. Oh, first minus 8. This should be from 0 to 25. It said I'm trying to access value 97. That was ASCII value of a character. All right, this works. And the other linear part is here. I need to check for various characters if they appear in the suffix from I to n-1. Again, that can be pre-processing. In particular, I can already use next occurrence, but also could make some new array. For every thing, if next occurrence of start or what? No, from I, I'm looking from I to the right. If this z is equal to this crazy infinity, let's just put n here. N will denote something after the array anyway. This is infinity. Then this doesn't occur. If it's smaller than infinity, so if it really appears from 0 to n-1, then in suffix of z is true. And we got rid of another linear part. Now the complexity is 26 times 26 times 26 and plus 26. Two for loops, but not nested, do not stack. It's plus, not times. So now we have a cubic after our pre-processing in n times 26. This kind of improvement from na square to n times a plus a cubic, which is for those particular constraints 26 times faster. A cubic is anyway not a significant part. 26 cubic is not a lot. And here now we have n times 26. Now actually those two parts have similar running time, let's say, for those constraints. But you can imagine some different constraints, some different kind of problem, where alphabet size is up to, let's say, 100, and n is up to 5000. Then this new complexity works, and it will run in 1 second. This old complexity would be too slow, because a square multiplied by n would be a little bit too much. Maybe you should increase it to like 300 to make that happen. Yeah, now for sure new complexity is good and the old one isn't. Leetcode said it is slower than the previous. I mean, when you deal with times like that, it's not really meaningful anyway. Those are fluctuations. So it's like, you know, measuring. You shouldn't measure with milliseconds something that works in around 1 millisecond. And here just starting a program, an empty program, takes similar amount of time as going through all of that, maybe. Just because starting a program takes a little bit of time. It's not slower. What matters is time complexity. In no coding interview, you will do something at the whiteboard and then, you know, the interviewer will say, oh, that would take 4 milliseconds in Leetcode instead of 2 milliseconds. No, time complexity is important, and we improved the time complexity. I think that Leetcode shouldn't show this because it's confusing sometimes. Why is no one answering me? Maybe because you're asking a question unrelated to the stream. That's usually called off topic and sometimes even spam. And yeah, use Google before asking a question. Would you ever try coding game? I did coding game a lot of times. Can we do this next? Maybe. Summarize the approach. Okay, right now what we have is this. As pre-processing, for every character and every position, I want to know where is the next occurrence of this character. For example, on this second, let's say here, on this position, I know that A for the next time will appear never. B for the next time will appear on this position. Let's number the positions. 0, 1, 2, 3, 4, 5, 7. Okay, so A will appear on 8th position, so never. B, starting from here to the right, will appear on position 6. C will appear on position, on what position? Exactly this one, 3. And D on position 4. So next occurrence of index 3 and A, character A is 8, character B is 6, and so on. This is what we first do. Find next occurrence from every position, for every character. Find characters that appear at all in this string. Again, this could be done by using next occurrence, just looking from index 0. Then repeatedly try to minimize, lexicographically minimize, the first character to take. So prioritize with taking A. Find the leftmost occurrence of A. We explained why it's leftmost. Like here it's this one, index 2. And check if from this to the right all remaining characters occur. So you will be able to finish the string. If yes, then take this character A. If not, then try B instead. Try C, D, and so on. After you're done and taking some first character, then repeat the process starting from here. Try then every next possible, so second character. If you took A, then you need to try B, C, D. But only you can use stuff on the right, only in this suffix. So they must be here. That's the solution. Fine, let's move on. Can we do a linked list problem? I don't know. Try this next. This was a string problem suggested earlier, but I didn't really want it. I slightly prefer Leetcode over binary search, just to make it the string consistent. Couples holding hands. If you want to suggest something, by the way, preferably say a few words about it. Why are you suggesting it? Easy, hard, what topic? Is it just a nice problem, nice solution? Mock feature of Leetcode Premium? I mean, you need to know algorithms. I don't think format matters. It's a cool gimmick, but really, what's the difference? And it's not that problems marked as Google in Leetcode are that much better for you to practice if you want to get to Google. You need to know algorithms. That's it. Any template for problems asking about lexicographical order? Well, if you want to lexicographically minimize something, then first you want to minimize the first character, then the second character, and so on. That's your template. Binary search made by competitive programmers? You mean the website? No, maybe partially. If you mean the algorithm, then it's older than competitive programming. Yeah. Okay, enough suggestions. I will check out what is right now in the chat. Bitmask DP from recent contest. Oh, that's a big topic. Bitwise ORs of subarrays. This is actually very much related to our current problem, right? All right. Later I will check other suggestions, but it's perfect that we have this as the next problem. It's surprisingly related to the previous one. So that's a new problem. We have an array, and we consider bitwise ORs of some subarray. Bitwise OR obviously deals with bits. So if the sequence is, let's say, 1, 5, 16, and maybe not 16, 20, and some more stuff. One of many possible subarrays is to take this. Those are values. 5 is 101 in binary system. 20 is 16 plus 4. Let's pad it so we would look at the same last bit always. 4 is 100. Bitwise OR of all of those is, for every position you take the bitwise OR of corresponding bits. 10101, which is 6 plus 4 plus 1, so 21. That's the bitwise OR of this subarray. And we need to find the number of possible values we can get, and n is big enough that we cannot do it in n squared. But you know, cubic solution should be very easy, straightforward. Just for every left end, assuming that n is length of the array, for every right end, compute the OR of a of l or this or that up to a of r. We're going linearly through that. That's n cubic. N times you need to go through the interval. Of course, starting from same position and then computing bitwise OR of 5, 520, 524, every next operation is almost the same, so we shouldn't go over and over again. Similarly, if I ask you to find the sum of numbers 524 and you compute 29, and then the next number is 2, and you need to compute sum of values 524, 2, you will not go again 5 plus 20 plus 4 plus 2. You will just take the previous sum, so sum of this, and you will add 2. Similarly here, you should know OR so far. When looking at new R, just do this, add, or in this case OR a of r. We start with 0, of course, and then we know that OR so far is OR from L to R. Let's say we need to print all those values. Then we print OR so far with a new line, whatever. Actually, we should put that in some kind of set vector. Then we need to then remove repetitions to count the different possible values. Right now I don't want more suggestions because I'm doing this. Invert binary tree, I see the title is. Not being able to do this in your coding interview. Well, I for sure can imagine a software engineer not being able to do this, because why do you need to be able to do that? That's stupid. But yes, if you prepare for a coding interview, you need to be able to invert a binary tree. Yes, last problem was 1081. What operator can we use to subtract previous ORs? That's impossible. So we have n square solution. And now I will give you 5 minutes to think about the solution to this problem, better than n square. And a big hint is that it's related to the previous problem. Next occurrence will come useful. I told you that this is a common technique, apparently also common in bit-related problems, at least with OR. It wouldn't be useful for XOR. Also, I would say that this is hard problem rather than medium. For me, it was easy anyway, because just it's standard. If something is not unusual, very unique, then it's easy for somebody who did a lot of competitive programming. But if you don't have that big experience, I would mark it as Leetcode hard. Can this be solved in 32 times n? Maybe. For sure it's possible in 32 square times n. Next occurrence of a bit being set, yes. Like in the previous problem we had next occurrence for every character, here we will want next occurrence for every position. for every bit position from 0 to 31. Or how big values are? If values are up to 10 to 9th, that fits in 30 bits, so bit is from 0 to 29. If we wish to remove A from A or B, how can we do that? We can't. Knowing A or B and knowing A is not enough to figure out B. If I tell you that A or B is this, and you know also A, let's say A is this, then what is B? You know something about B. For sure it has here 0, because otherwise it would trigger 1 there. Maybe this will be better format. Also, you know that this is 1 here, because for some reason A or B was 1. But whenever there is 1 in A, you don't know if this was 0 or 1. So, Lindan, you cannot cancel OR. You cannot subtract it in any way. Can we solve this in nlog n? Size of the smallest subset with maximum bitwise OR. I mean, I don't know why you put the statement in brackets. You're asking about some different problem, and yes, I know how to solve it, but it's not related to this problem. You will invent operation that will do the impossible. Good luck. But you should first figure out what you want it to return here. Right? So how can this next occurrence thing be handy? I claim that starting from every position, here let's use next occurrence. Let's use of L, and here every bit from 0 to 29. This tells us every bit where it turns on. If you know that the values are like this, let's say array of 0 is this, array of 1 is then that, array of 2, array of 3, and so on. Then when looking for, starting from here, L equal to 0, if you take just the first element, then whatever ones you have here, those will be there. If you also have the second element, so array of 0 or array of 1, then you will have also this one. But looking at every column, if you notice here, where is the next bit 1, next occurrence of 1, you will then know, starting from where the OR of those numbers contains this bit. So next occurrence of this should tell me where is the next 1. What is the first number starting from here, whether it's array of this index, or maybe the next one, that has 0 on this position, so I know when in OR I will have this thing. Can you solve this problem? Nope, I'm not doing code drift today. That's too much unrelated to this stream. Hi, KJ1809. Welcome to the stream. All right, so how will we use it? I iterate over it, assuming that I already computed, similarly to here, to the previous problem. For every position, 30 positions are enough, because 2 to 30th power is more than the limit for a number here. For every, I need to somehow use this. How do we do it? What information will I get? I will get information. Let's say that I have L equal to 0, and let's focus on this thing. For going from the right, this is bit 0. So bit 0 doesn't have any occurrence, so it's infinity or n. This is the first moment when I have 1 in this column. Then for second bit, for bit 1, it's here for index 0, 1, 2. Then column 2, bit 2, the last bit, the least significant is 0, then 1, 2. For 2, it's here, this guy number 3, 3, 3, and so on. Eventually I have here bit, what, for 5, 6, 7, 8, 9, 10. For 9 I have just the first row with 1 in this column is this thing, so 1, and finally 10, 0. For the 10th bit from the right, the first one is in the 0th row. I can grab those pairs by using next occurrence. And what does it mean? It means that for any now r, if somebody tells me r equal to 2, I will know which bits will be on. This will be on, this will be on, this will be on. Because this was information. If I get from 0th number to array of 1 or further, then this bit, 9th bit, will be on. So if I get to r equal to 2, then this bit will be on. So whenever this second value saying when for the first time bit is on, when this doesn't exceed r, this bit is on. And this gives me all the possibilities for what the value can be. Because from this I know, if r is 0, then just this guy is on. And this corresponds to a number 1 and zeros. Actually here we have more bits, I just didn't write them down. But just looking at those columns and those columns. So those are four last columns and 2 first. Maybe I should just, because of that, remove this. Alright. So now this corresponds to that. Also let's change numbering. Cool. Everything's alright? I messed up, didn't I? Yeah, because those are 4 rightmost columns. So I should remove this. That becomes annoying. Okay, now this is column 5, 4, 3, 2, 1, 0. Column IDs. Let's verify. Is it true that for column with ID 2, the first row with 1 there is row 3? Let's see, column 2, indeed, this is the first one. Alright, and now what I wanted to say is that for r equal to 0, and just this is on, so then we have something like that. Something is still wrong. 0, 1, 2, 3. This should be 0. Because in this column, this is the first bit. Alright, now this is good. So, what this information says is that if r is 0, then this will be on. The last column, when looking from the right, so actually the first one, this is not. Then this, yes, because this is 0. Then no, no, no. This is OR of numbers, array of 0 up to array of 0. Then when r is 1, what do we have? I need to look at columns with value 0 or 1 here. So those. Seems that this is the OR. OR of array from 0 to 1. You can verify that this is indeed OR of those 2 first rows. Then for 2, also we get this one. this is, and for 3 we also, what we get, this thing. Again, we go from right to left, which I shouldn't go like that. I hope that this indeed is OR of all the rows there. Can you please use dark mode? I don't think that's important if anyway half of the screen is dark. Okay, fine. So those were now columns 4 and 5. And because values here are only from 0 to 30, there won't be a lot of different values. Right? If, I mean, we have here 30 different values at most. So that gives us 30 different possible ORs of some prefix. In other words, no matter how many rows we have here, maybe there is a new one there, new one here, and so on, a lot of them. For every column, if you find the next occurrence of this bit and you mark it in some way, you will not highlight a lot of rows. Those have X's and nothing more, which means that anything without an X, without that first bit, doesn't improve OR, because this was already covered every such bit. What's the lesson from all of this? Which I think it wasn't the perfect explanation. I'm not happy with this. Just I shouldn't have reversed everything, left versus right, but you know, normally bit 0 is the rightmost one. Okay, what do we have? How do we use it? So we have those pairs. I have a pair, next occurrence, that would be the value, and let's say also the bit. Now if I sort it, so I sort by the time when I have this bit on, and now this would be like, let's say instead of 5 0 would instead be 0 5. Like 5 was index of a bit. So I have pairs like 0 5, then there's 0 3. I'm just transforming this thing after sorting. What else do we have? 1 4, it's this one, and then 2 1, 3 2, and infinity 0. This means if we get to row 0, I have bit on position 5 and bit on position 3. Then if I get to row 1, I have also this bit, and so on and so on. So the OR so far is initially 0. Always we get to somewhere and I say OR so far, turn on this bit. What this will do is, like when it's in sys5, it will turn on the 5th bit in this number. It will XOR it with 1 0 0 0 0 0. Right? And if there were no ties, then I could say this. Then all the values insert OR so far. Values is a set. I got only n multiplied by 30 values, just because there are only that many meaningful rows here, rows where for the first time some new bit is on. But there are ties. Like if there's 0 here and 0 here, it means that 5 and 3 appear at the same time, not separately. So I should say, while I plus 1 is still in the bounds, and it's the same moment, then plus plus I, and still do this. This will grab those two at the same time. Then 4, then 4th bit, then 1st bit, 2nd bit, and so on. Right. This is done, with exception of computing this array of next occurrences. But we will do just the same thing I did here. I keep writing big instead of bit. Okay, almost always I just rewrite this. The exception is if this bit is on here, and in the previous problem the exception was if this character is here. If array of I and this is a way to check if this bit is on. Then exactly here this bit appears. And what about n? I will use the same trick. This means infinity, it doesn't appear. Maybe I should use it there. If pairs of I first is n, then break, because it means you cannot get this bit. What's going on? Pairs versus pair. What are pairs? I create it only so I could sort it by the time when I will reach this bit. Expected 1, output 0. Okay, 0 is something empty, so I should also say values insert or so far. I always keep looking for the next bits, and sometimes there is value 0, or at least let's do, if this value is 0, then I can just take it. So I can just take 0. But yeah, that's an edge case I didn't think about for sure. If somebody told me that there might be some edge case, I would first investigate n equal to 1, but for sure not this 0 value. Time limit exceeded. What complexity do we have? N multiplied by something, sorting something of length 30, so that's 30 times log of 30, still not a lot. And here we have 30, and I keep increasing here I, so it will be increased only 30 times. Well, we can improve values maybe. Unordered set, so n squared, this is not n squared, this is n multiplied by 30. They want it in n squared? Nah, I doubt it. N squared is slower. It's for 50,000, n squared is a lot. What can I prove? Instead of 30, I could use maximum bit available. So just I could find maximum in an array and use at most that. This thing is a little bit slow, the set. We can try an ordered set. But even better, this should be a vector where I push back and then I remove repetitions after sorting. Right? Accepted. I'm not very happy with that. Let's try this. A vector where I push back. But then I need to sort and remove equal neighbors. I could use resize and unique in C++, but let's just say if I'm either the first element or I'm different than the previous guy. This properly counts new different elements, unique elements. I think that even though we sort, so it's clearly n log n, where n is the number of elements we have there, it should be faster than sets. It was a little bit faster. Not by a lot. I don't know how to do it better. We can make some kind of huge bit set. I could take 128 megabytes. But is this what they want? I can make a bit set of size this, call it visited or available, something like that. I will later look at solution. What change did he do? Pareto vector max is 32. What is maximum answer? 32? Can we? No, it isn't 32. It is 32 starting from every L. So maximum answer is n times 32. Isn't max ans 32 times 32? I don't see why that would be the case. In particular, consider an array of n distinct values. Then each subarray of size 1 has different OR. And please don't repeat your comments. Let's see how it works with visited. Oh, I anyway need to clear that in some way. But at least I won't need to sort. E visited of X. Now I'm using a huge Boolean array of size 1 billion, which takes 128 megabytes visited, and I need to clear it because Leetcode runs your solution many times for different test cases, and I don't want it to contain some trash from previous runs. Then I need to gather all the values to know how to clear it later. Deadly signal, is that because of it? If I choose something smaller, does it work? Oh, it doesn't allow me to take 128 megabytes. That's sad. I wonder how much I can take. So 64 megabytes is good. 128, nope. I wonder if I can cheat it a little bit. So vector has same space, it takes same memory as bitset. It is very compact. So what about this? I can resize this vector in runtime rather than here, compilation time. Okay, maybe this works. No, but those are ugly hacks. You shouldn't do it. All right. Fine. So this is not a way to go. The fastest code was this one, where I used, see, I sorted the values and I removed repetitions. Map has a huge constant factor indeed. Pigeonhole? What do you mean? Like, answer can be at most n times logarithm, and doesn't mean that it is billion. You shouldn't use maps if you care about running time. Final round this afternoon, pretty nervous. Good luck. Good luck, Zulander, in your interview. Yeah, I will try editorial solution. Top editorials are also very slow. Then why sorting is bad practice in interview? Why? Harsha Malaya. Why is sorting a bad practice? Frontier set. Calculate every evidently the brute force approach. I never saw that word in English. We can speed this up by taking note that. Okay, we have complexity and square, fine. Can we then we can find the next cur set by using this. Since this list is monotonic increasing, I wouldn't say that this is a good explanation, but fine. Oh, so they just want to save. No? Huh. That's some new, maybe not new. That's some solution completely different from mine. They use the fact that up to somewhere they know what are suffix solutions, I believe. If you have array of 0, array of 1, array of 2, and so on, then when they are for every position, they keep in a set, and that set is called current. What are the possible ORs of suffixes? This, that, and so on. Maybe we will have fewer than 4. Just no matter how long prefix is, the number of different values here is 32, or 30, for the same reason it was 30 for me. And then each of those I try to expand by also ORing it with this. And then with that, I have new set of possible values. This, that. Every value in a set, I update by ORing it with this, and I also consider this single element. Considering this single element happens here, current 2, the new current, add this x, and here for every element in current, so every y here, consider ORing it with this x. This way we get new current, no, this thing, and because it's always up to 30, we first ending at any position, we have 30 possibilities for the suffixes. So their complexity is n times 30 times. They insert something to a set, so it's n log squared. Time complexity is bullshit, of course, because set is logarithmic. Maybe, I don't know, maybe in Java this is unordered set, then sure, it's n log, but if you don't have collisions. But it's just like if I had, I tried here unordered set, and it took 1 second. So it's then same complexity as theirs. Just, this solution is of course much shorter and cleaner. But I think it's very hard to come up with it. And then I'm sure this should be hard. No way this is medium. This answer in C++ will result in time limit exceeded. Nice. Cool limits. Why the set size is at most 32? Well, I explained that in my solution, where for every position we are looking for the next bit, where the next time some bit occurs. I don't know what is frontier set. I think it's not name of a technique. Right. Java set is unordered, tree set is the ordered one. Okay, thank you. So then indeed, sorry that I said, of course, it's log square. Okay, it's log, but unordered and ordered set aren't that much different. For some reason, in coding interviews, they strongly prefer an ordered set, even though it can be much slower. All right. How are we with time? I guess one more problem. I'm going to scroll up and consider previous suggestions, because I didn't even check them out, because I saw this one and I was happy that we can practice next occurrence. which by the way resulted in a very long code, but I don't think many people come up with this themselves. Kunjay asked in my friend Google interview. I'm just going through the chat. Maximize grid happiness. What is this? Okay, that's something to consider. Number of non-overlapping substrings. Maybe we should do Bitmask DP because we did some bitmasks. I mean, we did something with bits now. Okay, let's choose from these two. I will read it. Maybe I will reject some. And if at least two are good, I will create a poll. Given 4 integers, you have this grid. There are 2 types of people, introverts, extroverts. The link will not yet work, by the way, the command. I don't want new suggestions. Assign some cells to people. Happiness of each person is calculated as follows. Introverts don't want to be neighbors with anybody. Extroverts want to be neighbors. So this is some constructive problem where extroverts should be far away from other people. Oh, and limits are very, very low, which there are at most 6 people, so maybe just about a brute force to try all possibilities. Actually expected limits to be a few hundred. So this is one constructive slash brute force problem. What else do we have? Maximum number of non-empty substrings with some conditions. If we take C, we must take all occurrences of C. If we take A, we take all occurrences of A. Okay, I think I solved it once during one of the streams. I know a solution for this, but okay, this is some kind of, when you split string into parts, it's usually DP. Here n is big, so maybe it's not DP. That's something. Okay, and the last problem. Jobs, every job has some amount of time. K workers, 1 worker. So split jobs into groups. Fine. So this is something. Indeed, Bitmask DP. All right, let's vote on this. Max grid happiness, constructive slash brute force, maybe, I don't know, maybe we'll need to iterate over all possibilities because constraints are that low. This is max non-overlapping string DP question mark, and finally it's mean time to finish, and that's Bitmask DP. Here you go. Link to the poll pasted in the chat on Twitch. If you're watching me on YouTube, then always, if you want to interact with the chat, you need to open Twitch chat. Link is almost always in the description. In the description of YouTube video. I mean, YouTube stream. Hi, Akansh. when started programming, I was around 15. Maybe a bit younger when I did first thing like play around with HTML. Don't go to that link, it's a virus. This link from me. I guess so, if you don't want to choose a problem. You got me. Actually, I created this whole Twitch and YouTube channel only to send you a link this one time. There is no poll comment. Will you get Twitch affiliate soon? Nope, I'm not going to. One advantage of that would be, though, to have built-in polls. Can't get the poll because it's not, there isn't any comment for that. Series of videos on DFS and other graph algos. When I have time, I make videos on YouTube. I don't see how it makes a difference to call it a series. Interview streams when I decide to go to IT company. I mean, that's the point. These streams should be most beneficial to people who prepare for interviews. Next training lecture. Don't know. Okay, results. Okay, small winner is slight winner. Yeah, I guess. Mean time to finish Bitmask DP. So let's go with that. And I'm happy because I think that max non-overlapping string was already done on this channel. So mean time to finish. I want a version where it's not from a contest. Okay, this one. So it's the same thing, just there will be black on the right. The links. Suggest good tutorials for Bitmasking plus DP. Did I make something? If not, then I don't know. Codeforces has a lot of tutorials. Fine. We need to split values like here into k groups. It's good to state the problem is in as easy way as possible. We need to split it into groups. Let's say one way here to split is to get groups 1 to 7 and 2 8 and 4 8. If we split like this, then the amount of time needed here is 10. The amount of time needed here is 12. So this worker will finish too soon. This will finish later, but our answer is the maximum of that, when the last worker will finish. That's 12. We found a split where 12 is the time achieved, but apparently 11 is possible. If k was 3, then it would mean that we need to split this into 3 groups. And I guess that then it's optimal to split as 8, 7, 8, and 2, 4. The answer is then 8. You cannot do better because 8 must be in some group. Well, what's the simplest, or at least slowest solution we can do? We can do k to nth power, where for every job we decide which worker should take it. The complexity of this is 12 to 12 power, and that's too much. We can maybe improve it a little bit by saying that every worker should get at least one job, or maybe also we can break from some cases if it's a recursive backtracking solution where we see that this group is just too big, but we will not improve it a lot. K to nth power is too much, just too slow. But I would implement it recursively. For the first job, first we decide which worker gets it, and then we recurse and decide about the second job, third job, and so on. Sorting will help in this? I don't think so. I don't think that after sorting it's anyway easier to make assignments. Max overlapping after this? No, this is the last problem. Does this come up in interviews? Sometimes. It shouldn't though. I think it's a bad interview problem and interviewers shouldn't use it. Alright. Let's try something that I think will not work. But if you watched my dynamic programming lectures on YouTube, you know that almost always I recommend to go from left to right, already be done with making decisions about the prefix, and saying what is important so far about my choices. Almost never we need to remember everything about the choices here, just the important stuff. If we split into two groups, then I would say that for any prefix, even if there's a lot of numbers here, say this, that, then I would only want to know what's the sum of values in first group and sum of values in second group. So the state of DP would be related to the current index I, like how many numbers I considered, and sum 1, sum 2. And it would likely be like DP like that. But this is not viable. Values are big, so those sums are huge. I shouldn't have that as dimension in my DP. And if k is bigger, then I have more sums. I don't want to have 5 dimensions or 10 dimensions. Nope. Instead, apparently, I need to use the fact that 12 is a very small value. So maybe I should just know well, what I can have in complexity. 2 to 12 power would be fine, 2 to nth power. So maybe I should say that for some bitmask of this, like maybe those values are taken and other values are not taken. Maybe like that. Well, if I know what values are taken, then I know there's some, I can compute it. But what about other values? This will not tell me the split into 3 groups or 4 groups if I just know a bitmask. Is binary search possible? I also thought about binary search here for a moment. Binary search over the answer, I mean, where maybe it's easy to check if it's possible to split into groups, each with size, with some, at most something. If we can make this check, then we can do binary search over the answer. But I don't think that this is much easier. Maybe it will become useful inside some kind of DP. Fun fact is 3 to nth power might also work. I actually thought that it's 3 to nth power. So do you want to solve it? Is it possible to solve this in 2 to nth power? Well, anyway. If we want to split into 2 groups like this, then it might be reasonable to go one by one. So let's say k is 4, then maybe I should go once through the sequence and decide about every next item, whether I should take it to this group or not. Then I should know the current sum of values, of course. And then I need to in some way remember that those are taken values. So let's say that I dealt with 2 groups already. I already fixed them. There is some current bitmask and it says that those elements are taken. They are used, I shouldn't use them anymore. Then I can go through this one by one and say if I should take this element to the third group. If yes, then I change this from 0 to 1. If I decide to not take it, then skip it and leave it as 0. Then for this I have, well, there is current k, actually the current group ID from 1 to k. There is the mask describing the whole thing. There is index that I'm right now looking at, and there is partial sum. The values that I took to this group, what is their sum? If also I am done with previous groups, then I should know what's the sum 1, sum 2, the sum of previous groups, or actually the max sum so far. Among groups that I already finished, what's the maximum sum over there? And I cannot have those sums in DP, like one of them would need to be dimension. Instead, indeed we should introduce this idea of binary searching over the answer. Let's try to check if answer, let's say 100 is possible. Then whenever we finish a group, we just need to guarantee that the group sum is at most 100. Then DP is built on that. Sum is the big value, but then I can move it outside and minimize it. So DP of group ID, mask, and current index, it will be defined as mean sum so far of this group, of this currently created group. This is group ID. If that's the case, then complexity seems to be 2 to nth power. Mask is 2 to nth power multiplied by k multiplied by n, multiplied by logarithm of answer to the binary search. Still, it's 2 to nth power is the only big term, everything else is small, like 10 or 20. Backtracking with workload. I mean, for sure I wouldn't call my solution that. It's not backtracking at all. But do I want to implement it? It seems quite annoying. Well, we start with, I guess, this minimum sum so far. Everything else is infinity, to denote that this is impossible to achieve. Oh, and actually that's inside a binary search. Let's binary search from 0 to billion 5. I don't know, sum of elements in jobs would be enough for the upper bound for the answer. I think that accumulate adds up all the values, so this is the sum. Right. Now we need to check if mid is a possible answer to achieve. If possible, then remember that as a possible answer and try to find a better one, so a smaller one. Else we need to get bigger answer. I mean, something should be possible, so this will be overwritten anyway. If you want to learn binary search, well, watch my my lecture on YouTube for binary search. Just, Google Erichta binary search, you will find something. DP of array. What here? What do you mean? DP is an array. DP is name of an array. Here are just those will be some kind of dimensions. I'm just putting name to those dimensions. Okay, how to check if possible? We need to run DP, of course. At the end, I will check if DP of all the groups, the full mask, so all elements are taken, and what will be I don't know. We check if this is not infinity, maybe? So if this is possible state to reach. 0, because then like after the last group, now we can look at element 0. After we're done with a group, we again jump to item 0, I think. Right. This is of course pseudocode. I need to have some for loops for that. Okay, the groups, this, and the last dimension was from 0 to n-1. For group ID, for mask, for index, okay, this is infinity, where infinity is, let's say, 1,000,000,005. Right. Now let's actually do the DP. Always when looking at some item, if it's not taken in a mask yet, if this is not taken, then consider taking it. Then I will move to DP of mask with this new element, and most of the time it will be I+1 unless this is already the last element. What also must be true is that DP of sum so far is my value. Let's remember DP of this is the minimum possible sum of elements in this current group that I'm still creating. And now I need to decide about ith element. So if sum so far plus jobs of I doesn't exceed the limit being mid, this is limit from binary search for what can be the sum of values in the group, and this element isn't taken. New state, let's say this, S2 is minimum of itself, and sum so far. This is just some helper reference to make the next line shorter. All right, if we can take this element, then consider taking it. This doesn't work for I equal to n-1. So maybe actually let's do here n+1. So at the end we will look at the nth element that doesn't exist. Okay. And at the end I have DP of group ID, mask, and n-1. I need to move it to the next line. So if this is not infinity, this is 0, because this is partial sum for the next group. I start from 0, as long as this didn't exceed sum so far. Didn't exceed the allowed limit, but always I allow taking an element only if it doesn't exceed the limit. So just infinity denotes impossible to reach state. Okay, we're getting somewhere. So this was considered taking an element. And consider not taking. This element we're looking at. That's just new state is same group, same mask, I plus 1. The sum so far remains. I believe we're done. Brackets 1, 2, 3. Okay, indeed 3 opening brackets but only 2 closing brackets. I think it's usually Leetcode's fault because I do my brackets and Leetcode sometimes does it too. And something's wrong. The last dimension of DP array is index we're looking at right now, the element to decide about right now. Right, something is wrong, and if I did all of that locally, now I would turn on I would run GDB and it would tell me which line is cause of an issue. Instead, let's try to understand it. Or let's start with this. Do we get here? And do we get here more than once? We print 4 and then it fails, right? Let's print ABC. Let's print group ID. Good old method of debugging by printing stuff in various lines. ABC 0, 1, 2, 3. So we got up to 3. Fine. So did we get here? Yep. But yep, wasn't done. We don't get here. Something bad happens for group ID equal to 3. Oh yeah. We only go from 0 to k minus 1. K times we add a new group. So now we print unnecessary stuff. Let's get rid of it. Also because it takes time. Output minus 1, expected 3. That's bad. Apparently answer stays as the initial value and never overwrite it. So never this happens. That's sad. For the first case, k is 3. So perfectly I want to once take this, once that, once that. It seems like DP of group mask should be enough to solve the problem. Maybe I'm missing something. Okay, but what do you then do? What do you do when you have DP of group mask? Because thanks to the last dimension, I know what element I'm looking at. If you mean that you can do the same and just not remember always everything in space, then yes, I agree. I think that space complexity maybe even can be improved to just this single dimension, 2 to nth power. Because I don't need to remember previous rows, the previous groups. Same, I don't need to remember previous i's. So I think that 2 to nth power is enough. We just kind of repeat something k times n times. Okay, everything infinity. This, that. One more improvement. If sum so far is infinity, and continue. Otherwise, let's print where we are. Group ID, mask, I, and sum so far. Why? Oh yeah, because we do this. So I just want to say that let's investigate meet equal to 3, because that should be possible. And let's here return -1. I don't want to investigate the whole binary search, just a single thing. Needed is a billion, the infinity. Right, for group ID 0, I want to just take the first element and later mask. Do I have then 1, 1, 0? Yes, this says that for the next group, after already being done with the first one, mask 1 is possible. This is a mask where only one element is taken. Also, 2 is possible, 4 should be possible as well. Why is 4 not possible? Four should say that n. When we have elements, when we are looking at I equal to n minus 1, like here, it then moves to I plus 1. After we take this element, it is moved to I plus 1, so it is moved to n. Which means that my code so far never took the last element, n minus first, and then moved to the next group. Let's run this again. Needed is 0, not infinity, so it would work here. Right. I'm now commenting because maybe we will need it again. Do we have a 3? We have a 3. Accepted. What's the time complexity? Logarithm of the answer multiplied by, this for loop is not more complicated than this, so log times k times 2 to nth times n. And then all of that is constant time. Log of answer, this is related to sum over jobs of I. Log of answer times k times 2 to nth power times n. But somebody earlier mentioned already that also 3 to nth times something is possible, but I will not explain it. I don't think it's something important for coding interviews. Not that this was a very typical problem. Oh, Mrzayas, you want to iterate over submasks? So that is 3 to nth power complexity, but my complexity is better thanks to that extra dimension. Yes, instead of deciding about workers one by one, you can iterate over what will be the next group that you will take. But then for every mask, you need to iterate over every other mask. So let's say, roughly speaking, you even have 2 to nth power times 2 to nth power. Should I explain Xiao's code? This thing. Okay, he iterates over submasks. So he has the complexity of this solution is 3 to nth power. And the idea for DP is the same. It's mask of already used things. It's just that we repeat something k times and then we don't need to iterate over index. I also didn't need to keep group ID as the first index. Maybe CP algorithms describe that if you want. No, I don't think so. This is slightly related, but it's not really that. Is it okay to use segment tree if the problem is easier? Very hard to say. I, as an interviewer, would likely want people to solve a problem in the same way, meaning that I don't want to give benefits to people who know competitive programming. I guess you should assume that there is a solution without a segment tree. But I guess it's only good if you know a segment tree. Just say, okay, I think I can solve it with a segment tree, and then interviewer will tell you if you should follow with that or you should think about some other solution. Right. Thank you everybody for watching. Join the Discord server. Check out the schedule of streams. I stream every even weekday. Oh, I still didn't add the programming tag. That's bad. And let's raid somebody if they do similar stuff. Still the tag isn't displayed. Anybody interesting streaming right now? Thanks Mirzias, Andreas for watching. Odd weekday if you start from 0? I guess so. Don't some religions start counting from Sunday? Why am I recommended my official live stream announcement video from 3 years ago? Right, somebody doing Leetcode? I am doing Leetcode. No, 2 days ago. All right, no raids today. Go for Lana Lux. What is that?
And you need to get something out really quickly. Is you want to focus on the primary gameplay loop. The primary gameplay loop is the small loop of things that the player is going to be doing over and over and over. It's sometimes described as the thing that...
So why is that a video in the corner? I don't know that. I don't see the setting. She has a lot of viewers right now. But yeah, fine. It's as good as not raiding anybody. So here you go. That's a raid. It didn't work. Oh, that I need